Hi, and welcome to this section of the Chemistry Tutor. In this section, we're going to conquer what we call ionic compounds with polyatomic ions. So you read this and you're like, oh my gosh, I'm really in for it. Ionic compounds with polyatomic ions is going to be really difficult. So even the basic definitions sound complicated. Well, I'm here to tell you that this is not that hard. It's just really an extension of what we've done the last lesson. In fact, most chemistry books actually lump this topic in with the last topic that we just did and throw it all at you at once. But I find that it's better to kind of put a little break there and separate the two things just so you can kind of get lots of different examples of each type. So what we have had in the last section is we talked about naming and forming ionic compounds. We basically said that, look, there's a metal on the left-hand side of the periodic table that likes to form positive ions, combining with a non-metal on the right-hand side of the periodic table, then they like to form negative ions. So you have a positive ion and a negative ion. Opposite charges attract, so those are the forces that hold these ionic compounds in place and make them stable, right? But in general, every example we did in the last section was one ion on one side of the table, one ion on another side of the table, and we stick them together. So it was always, sodium chloride, potassium bromide. You could go on and on. One element plus one more element. Well, here you'll see that it's very easy to get to slightly more complicated ionic compounds by a very simple deal. The thing that you need to understand is that certain elements like to clump together and form what we call polyatomic ions. Now, let's just take that word for a second. Polyatomic. Poly means many. Atomic means atom, right? So many atom ions is what it basically says. So there are certain elements on the periodic table that if you just kind of stick them together, they will tend to be sort of a stable ion and they'll have a charge associated with them. So let me give you some examples of those. What we're going to find is that these polyatomic ions can combine with other elements to form compounds with them. So let's just take a little example, and I think it'll be really easy. Let's look at what we call, just as an example, the ammonium ion. Ammonium ion. Don't worry about why it's named this way. These are all sort of historical names, things that have been developed over the years. But the ammonium ion is written like this, NH4+. That's called ammonium ion. You can probably find that, well, you can definitely find that in your textbook. What it basically says is that if you take nitrogen, 1 part nitrogen, and you basically mix it with 4 hydrogen atoms, then it's going to want to form a stable arrangement, but the end result of what it forms is not neutral. It still has a charge on it. It's got a positive charge in this case. And you can kind of think about that when you look at the periodic table. Nitrogen likes to form -3. Nitrogen likes to take on 3 electrons. Each of these hydrogen atoms likes to generally shed an electron to be a positive. So if you take 4 of these positive hydrogen atoms and one of these nitrogens that has -3, and you can somehow make them stick together, then the resulting arrangement is not going to be neutral. It's still going to have a positive charge on it. So that's what the plus means. It means +1. So this is called a polyatomic ion. It just means that in nature, sometimes you put these things together and it's still stable, it still likes to hang out together, but it still has a positive charge associated with it. So let's go ahead and write a few more down and see what some of these things look like. You may have heard of some of these things. Carbonate.